Hello and welcome back to the International PHP Conference. My name is Sarah Schlotthauer and I am an editor at jackcenter.com. The following session is about once upon a load test in real time, and today's host is Stéphane Hulard. Before I pass it over, just a quick reminder to please use the chat if you need technical support, but also please use the questions function to ask any questions that you have. And if there is time left over at the end of the session, then Stéphane will answer all your questions. And with that, I am pleased to announce Stéphane Hulard.
Hey everyone. Okay, so I see that the screen is correctly shared. We are here to talk about load testing. Regarding any application in language, and I'll talk specifically about one tool, that is Artillery, a tool written in JavaScript that is, I think, really simple to use, and I try to prove it during this session. Just a quick introduction. So I'm an independent consultant and contractor from France. I also work as a trainer to help the teams which I work with, or the other developers that need to progress on different topics regarding unit testing, continuous integration, or all the, I think, good practices in our current development world. And also I'm a contributor. I try to contribute on open source softwares, also during conferences like this one, to explain on details about my workflow, my favorite tools, and anything that I seem relevant. You can find myself on Twitter. I put under my photo my username, and if you need to discuss any topic after the talk, you can ping me here. And also on other tools, I put the link under the photo too. The slides are public, already available on the internet. I put the link in the chat, so if you want to follow the session directly from your browser, you can. First, I try to explain what is load testing, because there is a lot of different kind of, so it's important to start with the basic. It's a special kind of testing because it's not at the code level. We are not like in unit tests looking to verify a specific piece of code. Testing the application in globally. So we interact with the application automatically to verify that the behavior is correct and that everything works as intended. But that kind of testing is specific because it's under heavy load. We are not here to verify all the tiny details in the application, but just to verify that the application behaves correctly when there is a lot of users that arrive on that application, that check some pages, or any feature that is developed in the code. This test will help analyze the performance, because we always need to know how our application behaves when there is a lot of users, and also the limitation. This one is really important, because when you develop something that will be used by maybe 100 persons, maybe 1,000 or 10,000, you need to be sure that everything will work correctly for your users. So the limitations are one of the important points to always know with your code, to ensure that your users will always receive the correct behavior. Then you can optimize and check for regression. Of course, if you develop a new feature and this feature just add a lot of processing, maybe your performance will be low. Running those tests, those A/V tests, from time to time is important to check that the application always behaves correctly regarding the specified behavior. So we need to validate the behavior. So what is the behavior? The behavior is can be identified, I think, from critical scenarios on your application. We need to be sure that when users go on page A, then click on that button, then that form, that it can always go from the step 1 to the step 10x on the just finish in the required workflow. And we always want to optimize and check for regression, because those scenarios are here to validate that the application behaves correctly on heavy load, but also that the feature is still working for every user. So when there is a lot of users, when there is one user, those tests are here to validate the global behavior of the application. So how we are writing those tests? If we talk about HTTP, this is a common protocol for all the web-based applications. We have already different tools like Apache Bench or Siege that can be used using the CLI. There are you give the URL, some parameters, and they run a lot of requests. You can control how much users and the desired behavior. So HTTP is mostly covered for this the requirement of using A/B testing, but for the others protocols, it's not always easy to find the right tools, because specific protocols mean specific implementation, specific features, and we are here to talk about WebSockets. Now, WebSockets, what are the WebSockets? It's a standard real-time protocol. It has been standardized in 2011 using an RFC. So this is a protocol standardized a few years ago that can be used to make full duplex communication from client to server and server to client. This is just a protocol because it's described how we need to communicate between that client and that server, and it is language agnostic. There is implementation for that protocol in maybe all the current language that can be used to develop application. And the most important part for that protocol is that it only transfers data when it's useful to transfer them. This is important because when we talk about full duplex communication, when we need to communicate between the client and the server and between the server and the client, we are today, the most common implementation is using HTTP. So we need to create an API endpoint or a URL endpoint on the server side. The client call that endpoint, receive the response, and the communication is over. So if you need to have real-time communication, basically for example, for a chat client or for receiving critical details, if we talk about CI or CD tools, when your pipeline executes, you need to know which tests are failing, which part of the job are broken. So this is important data, but there is not much data that needs to be transferred. Only when an event occurred on the server side, the client must be notified. If we use HTTP, we need to use polling. So we need to call a URL every X second to receive, to verify that everything is fine. And we receive the information that there is some problem only when the XM call will fail because the information is only available at the server at that moment. So WebSocket is a protocol that helps handling those issues more efficiently. If you need to receive really important information from the server only when some event occur, it can be interesting to check that protocol and how you can implement it in your server. There is some trade-off regarding the community real-time duplex stream between the client and the server. It means a persistent connection. When the WebSocket is active, it means that there is a full persistent connection between the client and the server. And This is important. This is important because it's a really different paradigm than the default PHP one, for example. When you call the application, receive a response on the communication. Maintaining an active connection between the client and the server means different configuration, different tools to be used on the server to handle those changes. And to ensure that everything is fine. It's important to validate those configuration, those tools to that they behave correctly and in a few minutes. When we talk about persistent connection, there is on the server side long releases, very common by the default framework in the PHP world or in any web application like the MVC pattern, because it's not the main goal of those applications. So when you talk about WebSockets, when you talk about those that kind of tools, you enter a new different world where you need to handle things a bit differently. We'll see tomorrow in another talk about the WebSocket server implementation, if you want to join me. But let's return to the test. If we just want to talk about HTTP, I'll test the WebSocket the same way than we are familiar with. We want to be able to just go from step 1, then step 2, like if we go from page 1 to page 2. So we need to just simulate the client interaction. What does it mean? It's just that we need to have some kind of bots that will be scripted to handle the different steps for us and go from time to time by sending the first message, analyzing the response, verifying it, sending the second message and validating that everything is fine. That RTRE is an open source testing tool that can be relatively easily used in any project to validate the behavior. We'll solve there is some any configuration that need to be done, and you can quickly use it to execute tests on your code. It's a different kind of tool than we are familiar to, for example, unit or something like that, because it's totally separated from the code of your application. It's a really different tool because it's a user that will try to verify that everything is fine. First, we need to install it. So an npm package, it came from the JavaScript world. After running those commands, you can saw a marvelous dinosaur in your terminal. If everything configured properly and start writing your configuration and executing the test directly. A test in the RTRE language is called a scenario. So different steps that need to be performed to validate the application behavior. As we can, we are used to, there is a configuration part of that configuration file that will help choosing which is the target that we'll try to test. Is it the actual development server, which is on your local machine? Is it the production server, a testing server, or anything else? So you can configure which URL will be triggered, will be called for the test. This configuration is actually an HTTP configuration. So we'll target the HTTPS URL example.org. We'll try to get a get. We try to run a get call on the URL, and we will retrieve the response. If everything is fine, the test is okay. So we are testing very detailed information. We just go to the URL. If the URL is as a status code of 200. The HTTP connection is over and everything is. One important part of that configuration under that section, because the phases just describe how much user we want to send to our application and for how long, because we are making load testing. We are not just testing that the application behaves correctly. So we need to be sure that we try with the good number of users, with a valid user distribution, to ensure that the application behaves correctly under heavy load. A phase is described using three properties. The first one is the duration. It's not the actual test duration, it's the duration under which the user will arrive on your application. So if the last user arrives after 5 seconds, it's the number of seconds here, he will start using your running the scenario at the 5th second. So it's not the real duration of the testing session, it's the duration of the user arrival. Then you have the arrival rate, which will tell how much user you want to arrive on your application every second. Here I have 5 users per second, and the RAM2, which will tell how much user you want at maximum. So here I want 10 user max. There arrive 5 per second. So after the second, I will have my 10 users and everything will run correctly. The last property, name, is interesting to have when you see a report, because it's important to know which phase was used when you analyze the results and verifying that everything is fine. So for the phase, those three properties, duration, arrival rate, and RAM2, are very important to understand, because that's how you distribute the users. That's the power of users you'll send to your application. So you can play with those values to find the right combination to use to validate your code. When you run it, after you get a simple report. There are not a lot of details, but I think the most important one are here. We are talking about heavy load testing, and we get the number of scenarios, how much scenario have been completed. The simple report was generated with 25 users. So everything is fine. The 25 per second, which is interesting because it can help identifying bottlenecks regarding a specific scenario. And you have the details for the response time distribution regarding some statistic details, the minimum, maximum, the median version, or the percentiles that can be used to identify how long the execution of the scenario will take for most of the users. The last part, you receive the HTTP codes that are returned if you speak about HTTP. That's interesting because RTRE doesn't consider a test failing if it doesn't receive the can control this behavior, but having the code can specific part of the scenario, for example. So we talked about HTTP test just by testing the one endpoint, one URL, and now we are here to talk about WebSockets. There is tiny difference when you use RTB from the first configuration that we saw to use the WebSocket. The first one, target must be a WebSocket URL. So of course we are testing WebSocket, so we need to connect to WebSocket URL. When we describe the scenario, we need to add an engine property to describe that we are using the WebSocket engine from RTB. this will to use a new message under to the WebSocket server. Have get, post, delete, all HTTP verbs to execute some queries. But when you speak about WebSocket, the only action available to communicate with the server is the send keyword. So the configuration is not so different than the first, just specific to the WebSocket implementation. We can go further. We can use some processor. Processor is a word in the artillery configuration, which allows us to enrich artillery with our own code. This is very interesting because we can add some verification if we talk about after the scenario execution. Very useful if you need to control that the response sent back from the server is containing valid detail, valid information. By default, artillery doesn't check anything regarding the response, but you can add your code directly here to validate the behavior. You can also add a specific function as a step in your scenario. So you can execute some validation, you can execute any code. This is a JavaScript function. You are in the Node.js world, so you can install package, perform network calls, you can do anything you want inside a specific step, and you'll get a configuration like this. We just add a processor property under the config section, and we'll get a new keyword variable under the flow that function, and we can just in my dash functions.js file to execute it inside our scenario. The JavaScript code will look like this. We need to use the module.exports features from the Node.js world. We expose some JavaScript functions from our my dash functions files. And our function will have a specific signature. For example, do something here. We'll take the context. We'll just come to that a bit later. The event emitter that is bundled into artillery, which allow us to interact more deeply inside the artillery framework. And the next callback that is mandatory to go further in the scenario. We can saw that those functions like a kind of middleware, if you are familiar with that kind of pattern, because it's just running between two steps, and you need to call the next step if you want to move forward. What's interesting here is that the context.ws property contains the actual WebSocket connection. Just a few, the slide before, I talked about the hooks, which are useful inside the HTTP testing process, because you can execute code before request, after response. There is nothing like that in the WebSocket world. In the WebSocket implementation inside artillery, you need to connect anything you need to test your code. So if you need to validate the message received from the server, you are required to execute some function, attach some event handler when the WebSocket message are received, analyze the WebSocket message, verify that everything is fine. It's on your side, inside your own code, that all those verifications must be performed. We'll saw this during the little demo I made in a few minutes to illustrate the behavior. Inside the configuration, we can also add some variables on some environment-specific configuration that is useful because inside the same scenario file, you can just describe how to test different environments without duplicating all the rules. For example, here, the variables under config define the list of required variables with the default values, and then you can override for each environment the list of the variables to be specific when you specify attribute to use any environment. For example, when I run artillery, here, if I specify the -e flag with the environment name, it will use the list of variable that is specified inside the configuration. It is very interesting because you need to define a flow, which is a scenario inside your heavy load testing session. And with that, you can execute the same flow under different configuration, different URL. I checked a lot of different details inside those configuration. Maybe it's a bit abstract for a moment because we didn't see any heavy load testing running for the moment, but I prepared a little demo up. The code is available on GitHub. The URL will be shared at the end of the session. And I have a really simple repository where I just installed artillery, the framework that we use, and a faker. This library is here to help me generate some random data to be used inside the code I share with you. This is clearly not mandatory, but it helps. I have a scenario a real configuration that can be executed, sorry. So you retrieve the target, which is example.odc, you retrieve the phased configuration, and we have our simplest scenario possible, which is a get call to one of the URL that will require to validate. But the HTTP is not the most important thing that we need to validate. We wanted to talk about WebSockets. So this first -WebSocket.yaml file contains the really simple WebSocket test implementation. For the demo, I just specified here a very, very small duration arrival rate. It's clearly not easy, but it helps just running quickly to show you that everything is fine. If I open my terminal here, and I run. WebSocket.yaml. So you can see that artillery is currently running the test. And when everything is over, we get that report for every scenario that was executed. We retrieve all the statistics, minimum, maximum, the number of exchange message, the number of scenario launched, and everything seems fine here, but it's a really, really simple scenario. The one that I want to show you is a bit more advanced, and I just created a tiny WebSocket server from on my computer, which is a kind of a chat application. The user can connect on that chat, can set the username, and can exchange message with the other connected clients. Same here, I put duration 5, arrival rate 5, but it's not important. If you need to do some real load testing, you need to tweak those values to validate the behavior of your application. Here it's a demo, so just a quick test. I added a processor file to just define some tiny methods. And inside that scenario, I specify that I'm testing WebSocket. the scenario is splitted in seven different steps. The first is sending hello, so we don't know who the client is, but it just send hello to the server. Then it stops for 1 second. It will execute a function. I'll show you that function after. And it sends to the server a specific message /name with a variable here that is initialized from the context. We'll just show in the JavaScript code after. This specific message /name will tell the server that the user specified its name. So after that, the server will know that this user, this connected client, have a specific name. It will send then 2 final messages before finishing the connection. So fun, I'm the name that was defined. No, not something really important here. It's a very, very simple test, not a production-ready one. The application is not production-ready too, but just to illustrate the different possibilities of the framework. If I look at the chat processor.js file, I require at the beginning the faker library to help me generate some random name for my client. I expose the function initialize context with the name initialize context. This name will retrieve it directly in the configuration. And in that function, we take 3 arguments. Those arguments are very important. The context for the scenario execution. This context will help us retrieving some global behavior like the WebSocket connection I show you in the slide, but also it helps us defining some variable that can be shared by the different steps. Here, I set a variable called name with a call to the faker library. So this function will just generate random user name with a last name and first name that will be set for that current client. I defining some variable that will be used afterward. If I go back to my YAML file, the function here is called. After that function called, I can use the variable inside the message using the curly brace syntax, and it will be sent directly to the server. If I run the server here that I've developed on my computer, if you need to know how that server works, I invite you at my tomorrow talk regarding WebSocket implementation in PHP. And I run here the chat-websocket.yaml file, which contains my valid information, my valid testing scenario for the chat application. We can see that there is a lot of activity on the server. If I just move a bit beginning, we can show that the server is logging every message. This was for the demo to show you that something happened. Here, he received a message named hello. We check that there is a user that is connected with a specific identifier. Everything can be kept tracked here. You can show that the server also set some name for some users. So the application logic, even if it's really simple here, can be tested just by defining the scenario that is used to validate that everything is fine. Here, my scenario was, I just want to set my name, then I want to still be able to communicate with the server. if we imagine a more complex integration, we can just talk about, I think, CI or CD platforms that send information back to the user in the web interface. You can just define some complex message that will be exchanged with the server, or some JSON payloads, anything that is relevant for your test, to ensure that the server will behave correctly and validate that everything is fine. If I move back to my console, I just added a little piece of code here in the initialize context JavaScript function. As I said in the slide, I have in the WS property on my context the actual WebSocket connection. So here I just add an event listener on that WebSocket connection to validate, to act when the server sent a message to the user. Because when we look at that configuration, we send information to the user. That's the goal of this scenario, but we haven't any way using artillery behavior to just read the server sent message and to validate that the message are correct, to interact correctly with the message. Here I just added a console log to display the received message in the console. You can imagine adding on logic to validate a specific kind of message, to enrich the context with a specific message contain information or anything that is required for your application. It's over for the demo. So just to make an overview of what we saw during this presentation, RTV used some YAML configuration. Not the best format in the world, but I think one of the most used when we look at configuration. You can clearly define some test steps inside the flow section of each scenario. You can configure and adapt per environment. So if you test a development server or a production server, you can define any specific details that will be used for each environment. And everything regarding those configuration is well documented. The RTV documentation online is very clear, not really complex to understand, and you have a lot of examples to just move forward and run your flow test. You can extend the RTV behavior with code using some hooks on the context, which is really important during the execution. You can enrich the context, and we saw this with the name property. You have a simple CLI interface that can be used to run any scenario. You just specify the YAML file and everything is fine, which is completed with some runtime flags that can be used to define the environment, define some variable specific to the current execution. Simple CLI interface, relatively similar to any other tools. Is there some limitations regarding artillery? So of course, yes, there are no real users. This is important. When we define the scenarios, there is no real users that will use your application. So the scenario is really robotic. You just execute step after step and move between the different sections, execute the different actions. This is not a real test. But when we look at the load testing, we can't just put 100, 1,000 or 10,000 users just be in front of the application and just tell them, go test. It's important to have tools to emulate those behavior. Those tests are not not the best test that can be done. User will keep track of other details. We can review some specific errors, some specific message, some web behavior that the bots inside artillery we can't check. But it's better than execute some bot than executing nothing. the scenarios are just a sequence of tasks. It's not really easy to build complex scenarios, but as I said with the not real user, it's better to execute specific and simple scenarios than executing nothing on your application. And regarding WebSockets, it's not really easy to act on the received message. So RTRE is really simple to use because you just write some YAML file and you just try testing in seconds. But if you need to, if you have a very complex WebSocket workflow, if you need to analyze the server message, retrieve data, enrich the context, execute some actions after that, it's not really easy to validate that behavior. It's possible. You just need to write a lot of JavaScript code. But we saw that the functions that are used inside RTRE are not really complex to implement. So you can test now your WebSocket application. Just I just finished the presentation. If you look at the scenarios, I added the GitHub link here. I hope the sound was not too bad. If you have any question, just add them in the live discussion on Swapcard, and we'll try to answer them.
Thank you so much for a great talk. Yeah, now would be the time to ask questions if you have them. And of course, let's have a round of applause in the Swapcard chat.
I saw that there is one question. Have you tried to run this on some real servers staging to be more closer to the real interaction? Is there any limitation or different behavior? Yes, I tried. At the beginning, when I prepared that talk, I wanted to share with you a more complex scenario regarding a quiz application, which use the WebSocket to send a question to the user, receive the response, validate response time, and anything like that. But it was very complicated to make it fit in the 40 minutes session. So I just used a tiny example. But yes, I run even on the production server the RTRE test. It's not a real problem to test with load testing any environment. The only thing I think it's important is just have the DevOps team or the server guy closer to you, because if you have trouble regarding the test, maybe you need to just restart some services and make sure that everything is fine. It's the only point I think which is really important if you try to run those tests on different servers and on critical environment too.
Okay, great. Well, if there are no more questions, thank you everyone for attending the session. And thank you, Stéphane, for a very informative session. And have a good lunch break, everyone.
Thank you.
Thank you.